Welcome back to the Deep Dive.
Mm.
It is February 21st, 2026. And I want you to take a second right now and just look around, wherever you are. Or maybe you just listen.
You pay attention to the sound.
Exactly. Because if you are in a coffee shop or an office, or even your own living room right now, you might notice something a little different about the ambient noise of daily life lately.
It is a lot quieter, isn't it?
It really is. Less clicking,
Yeah.
less frantic typing. We just aren't hammering away at keyboards quite as much as we were, say, 2 years ago. And that's because the air has completely shifted. We aren't just chatting with our technology anymore. We aren't just prompting it and waiting for a neat little paragraph of text.
No, we really have moved past the era of the chatbot, which honestly feels very, I don't know, very vintage 2024 at this point.
Vintage 2024.
Yeah, that very basic text in, text out dynamic. It's obsolete.
Right. Because we have officially entered the era of agentic AI. And that is the mission for today's deep dive. We're going to completely unpack what that actually means for you, because the wow factor today isn't about generating a haiku or a polite email to your boss anymore. It is about software that actually does things.
That is the key distinction right there. It is the difference between a tool you pick up and use like a hammer or a calculator and a digital coworker you actually hire to manage a project.
Oh.
Or a digital house manager that runs your home infrastructure in the background. We are talking about genuine autonomy here. We are talking about agents that perceive their environment, make a decision, and then act.
Act without us. And we have a massive stack of research to get through today to explain this exact shift. We're pulling from deep technical reports by MIT Sloan. We have market analysis from Forrester, operational data from Redwood Software, and the very sobering International AI Safety Report that just came out.
A lot of heavy reading for this one.
So much reading. But we are going to synthesize all of it. We're going to look at how this technology has physically invaded our homes, from smart appliances to invisible computers sitting on your face, and how it has completely reshaped the modern office.
It's a comprehensive look at a world where software finally has agency.
But I think the big question looming over all of this, and we were going to keep coming back to this point today, is a question of control. Because if AI is now acting on its own to buy things, sell things, negotiate contracts, and write code, who's actually in charge?
That is the multi-billion-dollar question, and as we'll see today, the answer to that is getting a little blurry.
Okay, so let's start with the big picture, the great shift. If we look back at 2023 or 2024, the entire buzz was generative AI. It was all about creation, right? Make me an image of a cat on a skateboard. Write me a blog post about marketing. But 2026 is fundamentally different.
It is. The defining concept for 2026 is the shift from a system of record to a system of action.
Okay, let's unpack that immediately, because system of action sounds like a massive marketing buzzword. But I know you're going to tell me it's actually an engineering paradigm.
I am. It is an engineering paradigm. To understand the system of action, you really have to look at the frustration of the old system of record. Think about your classic enterprise resource planning systems, your ERPs.
Oh man, the acronyms.
Right, the acronyms. But for decades, these systems were just massive, incredibly expensive databases. They were basically scoreboards.
Right. They told you the score of the game. They'd say, we have 500 widgets left in the warehouse, or we lost $10,000 last quarter. But the software itself didn't actually do anything about it.
Exactly. It was a passive repository of information. You, the human being, had to look at that scoreboard, panic about the widgets, call a team meeting, decide to order more widgets, and then manually type that new order into another system. The system was just a fancy digital filing cabinet.
So the human was essentially the bridge between knowing something and doing something.
Precisely. The human was the manual API. Now fast forward to today, February 2026. These platforms have evolved into systems of action. They don't just store the data anymore. They execute complex tasks based on that data. And this is where the definition of an agent becomes crucial. A chatbot waits for your prompt. An agent perceives its environment, makes a decision based on goals, and acts.
So in that widget example, the agent sees the inventory is getting low, it checks the seasonal sales forecast, sees a demand spike coming up next week, and just, buys the widgets.
It buys the widgets. But it goes further than that. Maybe it also notices that your usual supplier just raised their prices by 5%. So autonomously, it checks 3 other pre-approved vendors, negotiates a better rate based on your usual volume, and then places the order. It completely closes the loop.
Without me clicking approve.
In a lot of cutting-edge cases, yes. According to a McKinsey stat we pulled from the reports, 62% of organizations are now experimenting with these exact types of agents.
Hold on, though. 62%. That sounds incredibly high.
Hmm.
Does experimenting mean they have fully autonomous robots running the entire company? Or does it mean the IT guy installed a plug-in just to see what happens? Because there is a massive difference between playing with a toy in a sandbox and running a Fortune 500 business.
That is a very fair skepticism. Experimenting definitely covers a broad spectrum of maturity, but the fundamental shift is that companies are moving beyond, let's chat with this uploaded PDF, to let's see if this agent can actually handle our end-to-end invoicing. It's moving from the is this cool phase to the how do we run our daily operations with this phase?
Okay, so the ambition is absolutely there, but how does it actually work technically? Because I remember we used to have all these separate apps, your CRM, your email, your spreadsheets, your inventory tracking, and they were notoriously terrible at talking to each other. We literally spent the last decade building fragile APIs just to get two apps to shake hands. How is the AI suddenly jumping seamlessly between all of them?
That is where things get really fascinating on a structural level. There is a piece of technology that has emerged as the glue for this entire agent economy. It is called the Model Context Protocol, MCP.
MCP. It sounds like the villain in a retro sci-fi movie.
Yeah, a little bit like Tron. But honestly, the best way to think about it is as the universal USB port for AI.
Okay, I love a good analogy. Break that down for me.
Before MCP became the standard, if you wanted an AI model like a Claude or a GPT to talk to your company's internal customer database or your private file system, developers had to write custom bespoke code for every single connection.
Which sounds awful.
It was brittle. It was what developers call spaghetti code. If the database changed its internal structure even slightly, the AI connection completely broke. It's like trying to hardwire a lamp directly into the plaster of the wall every single time you wanted to move it across the room.
An absolute nightmare.
Yeah.
And incredibly expensive to pay developers to maintain.
Massively expensive. MCP changes all of that. It is a universal open standard. It allows AI models to essentially plug and play with external tools and data sources. But the real magic isn't just that it connects things easily. It is how it handles the flow of information. It drastically reduces what we call token consumption.
Token consumption. Right, so a token is basically a piece of a word, and it's how the AI companies charge you for computing power, right?
Exactly. It's the cost of doing business with AI. In the old days, meaning, 24 months ago, you often had to feed the AI an entire massive file or huge database dump just to get it to answer one specific question.
You were paying for it to read the entire library just to find one sentence in one book.
Right. It was wildly inefficient. With MCP, the agent can reach into the database, grab just the specific row of data it needs, and process only that. It is surgical.
So it is cheaper because it is reading less junk, and it is faster because there's less junk to process.
Exactly. It reduces the latency to almost zero. This protocol is basically the invisible infrastructure that allows an agent to say, okay, I need to look at the sales figures in Salesforce, then draft a contract based on that in Word, then Slack the manager the final draft, and it does it seamlessly. MCP is the nervous system connecting the AI brain to the software hands.
Okay, so we have the software infrastructure figured out with MCP, but software still needs physical hardware to run on, and 2026 has seen a massive physical shift in our computers, too. I'm seeing these little stickers on new laptops everywhere now. AI PC.
Yes, the hardware absolutely had to evolve to keep up with the software. We're talking about the rise of the NPU.
The neural processing unit.
Exactly. For a very long time, computing relied on the CPU, the central processing unit, for general everyday tasks. And then we had the GPU, the graphics processing unit, for heavy lifting like rendering video games or video editing.
Right.
But AI workloads are a completely different beast. They rely on complex matrix math. They need a fundamentally different kind of silicon architecture to run efficiently.
And that is where the NPU comes in.
That is the NPU. If you have bought a personal computer in the last year, a Copilot plus PC, something running a Snapdragon X Elite or the newer Intel Core Ultra chips, you have an NPU inside it. We are talking about physical chips sitting on your desk capable of 40 trillion operations per second, 40 TOPS.
40 trillion operations every single second. That is hard to even wrap your head around. But my question is, why do we actually need that raw power locally on the device? Why not just use the cloud? We have spent the last 10 years moving everything, our photos, our documents, our processing to the cloud. Why bring it all back down to the laptop?
There are three critical reasons for that reversal: privacy, speed, and battery life.
Okay, let's talk privacy first, because if I have an AI agent actively looking at my personal bank statements or scanning my private medical records to summarize them, I get a little nervous about that data pinging off a server in a massive data center somewhere across the country.
And you have every right to be nervous about that. That's the beauty of the NTU. With that local chip, that highly sensitive data stays physically on your device. The thinking, the actual AI processing, happens on the silicon sitting right in front of you, not on a server farm in Virginia. That local privacy is a massive selling point for both massive enterprise companies and everyday personal use.
And the second point, speed.
It's instant. Because there is no round-trip data transfer to the cloud, you don't have that little spinning wheel while the AI thinks about your prompt. It reacts in real time.
And battery life. Running 40 trillion operations sounds like it would melt my laptop and kill the battery in 10 minutes.
That's the magic of the architecture. These NPU chips are incredibly power efficient. It allows these invisible background processes, the agents we are talking about, to run continuously all day long without draining your laptop battery.
So we have the software infrastructure with MCP,
Yeah.
and we have the physical hardware muscle with the NPU. This perfectly sets the stage for what the Forrester report calls the new workforce.
Yes, and this is the part where the actual societal impact starts to get very real and very visceral. We are witnessing the rise of the digital employee.
Digital employee. I have to be honest, that specific term gives me a bit of a shiver. It sounds so permanent. It's not a tool. It's not a software suite. It's an employee.
That is exactly the terminology the major HR platforms are adopting right now. Top human capital management systems, the HCMs that big companies use, are now officially tracking digital workers right alongside human ones. You log into the system, pull up the company org chart, and right next to Bob from accounting, there's a literal bot.
That is wild. Bob and the bot.
And the distinction Forrester makes in their report here is vital. It is the shift from task-based AI to role-based AI.
Okay, break that down for me. What is the functional difference between a task and a role for a piece of software?
The old way, the 2024 way, was task-based. You sit down and you ask the AI, write this specific email to this client. That is a single task. In that scenario, you are the micromanager dictating exactly what to do. The 2026 way is role-based. You deploy an AI sales assistant. Its defined role is to constantly triage incoming leads, update the CRM database, and autonomously schedule follow-up meetings. It has an actual job description.
So it operates autonomously within the boundaries of that role. It essentially wakes up in the morning, metaphorically speaking, looks at its own to-do list, and starts working without you having to prompt it.
Precisely. Let's look at a very concrete example from the tech world. Imagine a tool like Devin.
Right. I remember when Devin first made waves a while back, the autonomous software engineer.
Devin is a perfect encapsulation of this shift. In the recent past, a human developer might use AI to autocomplete a tricky line of code. That is a task. Devin, however, acts as a full-fledged junior developer. You assign it a ticket in your project management software that says, fix the authentication bug on the login page.
And then what?
Devin reads the entire code base to understand the context. It plans the software architecture to fix the bug. It writes the actual code. It writes the testing protocols to make sure the code works. It runs those tests. And if the tests fail, it debugs and fixes its own code. And once it passes, it deploys the fix live.
It effectively does the entire workflow loop that a human junior developer would spend 3 days doing.
It does. And we are seeing this exact same role-based autonomy in customer service too. The report mentions a platform called Robalon.
Robalon, that sounds like an evil sci-fi mega corporation.
It does sound a bit menacing, but what Robalon does is create custom agents that handle voice and chat support. But these aren't those awful, frustrating chatbots of the past that got confused if you didn't use the exact right keyword. These agents mimic the specific brand's tone of voice perfectly. They can resolve incredibly complex, multi-step customer tickets. They're literally hired to be frontline support agents.
Wow. And then inside the really big enterprise companies, you have Microsoft Copilot and SAP Joule living deep inside the ERP systems, handling multi-million-dollar finance anomalies and rerouting supply chain logistics autonomously. And here's where it gets really interesting and honestly maybe a little messy. Do we actually trust them?
Yeah. That is the trust gap. And the data from the report suggests we absolutely do not.
I saw this statistic in the research and it blew my mind. Only 17% of workers trust AI to work without oversight. 17%. That is an incredibly low number for a technology that we are ostensibly deploying everywhere, across every industry.
It is remarkably low.
Yeah.
But for very good reason. The reality on the ground is that 63% of the time, humans are still actively editing or fixing the output generated by these AI agents. We are absolutely not at the magical set it and forget it stage yet. We are very much in the watch it like a hawk stage.
Which naturally leads to the shadow AI problem. We used to always talk about shadow IT. An entire department secretly downloading apps or using personal Dropbox accounts without the IT department knowing about it. Now it's shadow AI.
Exactly. Teams are under immense pressure from management to be hyperproductive. So maybe the marketing team goes rogue and deploys a slick little open source agent they found online to dynamically optimize their ad spend. And completely independently, the sales team deploys a different AI agent to dynamically optimize product pricing.
Oh no, I see where this is going.
Right. Suddenly you have two autonomous agents from the exact same company actively fighting each other in the background. One trying to slash prices to close more deals, the other trying to raise efficiency metrics, and the central IT department has zero visibility that either of these bots even exist.
It's total fragmentation.
Yeah.
And it creates massive security and financial risks.
Massive risks. And speaking of risks, the MIT Sloan report brought up a concept that I think is absolutely brilliant. They call it turbocharged technical debt.
Oh, this is a critical concept. Because usually technical debt is just, it's old code you need to fix later. It's the, we built this fast and dirty for the launch, we will clean it up next year excuse.
Right. That is the traditional historical definition. But with AI agents, you can generate code so incredibly fast. An agent like Devin can write thousands of lines of code in a single afternoon. But if that code is slightly flawed or poorly integrated with legacy systems or just not documented well for humans to read, you aren't just creating a little pile of debt anymore. You are creating a mountain.
You are scaling your structural problems at the speed of AI. You are basically building a skyscraper out of wet concrete because it's super fast, but you aren't bothering to check if the foundation is actually straight.
That is a terrifying but accurate analogy. And fixing that AI-generated wet concrete later is exponentially more expensive than doing it right the first time. MIT Sloan argues that AI governance can't just be a static PDF policy anymore. You can't just send a company-wide memo saying, please be careful with the bots. Governance actually has to be code itself. It has to be an embedded operating model that physically restricts what the agent can and cannot do within the system.
So the guardrails need to be as digital and automated as the employees themselves.
Precisely. If the agent doing the work is made of code, the manager supervising the agent must also be made of code.
Okay, so that covers the office environment. We have autonomous digital employees, we have mountains of automated wet concrete code, and we have very nervous humans trying to supervise all of it. But this technology hasn't just stayed at work, it followed us home. Let's talk about the intelligent home, because this isn't just about clapping your hands to turn on the living room lights anymore.
No, not at all. We have firmly moved from simple automation to true autonomy in the domestic sphere as well.
What is the exact distinction there for the consumer?
Automation is simple logic. It's turn the porch lights on at 6 p.m. It is just a dumb timer. Autonomy is context-aware. It's the house knows I left work early because it checked my location. It knows the traffic is light, so I'll be home in 20 minutes. It knows energy prices on the grid are low right now, so it autonomously pre-cools the living room to save money and maximize comfort.
It is predictive. It is constantly thinking 3 steps ahead of you.
It is highly predictive and highly context-aware. Just look at the major appliances we buy now. The common refrigerator has undergone a massive, massive makeover in the last 2 years.
The Samsung Bespoke AI, I saw this in the notes, it has a feature called AI Vision.
Yes. There are actual internal cameras inside the fridge that identify the food you put in it. It knows you have bell peppers and raw chicken in the crisper drawer that are mathematically about to go bad.
I feel like my own refrigerator, judging me for my rotting vegetables, is an entirely new level of dystopian consumer guilt.
It might induce a little guilt, yeah. But the utility is actually very helpful. It uses an integrated feature called Food Note to autonomously suggest specific recipes based on exactly what ingredients you actually have before they spoil. The entire goal is to proactively reduce food waste. GE Profile has a similar feature they call Scan to List. The appliance is essentially managing your kitchen inventory like an Amazon warehouse.
And the laundry. Please tell me the 2026 washing machine finally folds the clothes, because that is literally the only AI feature I actually care about at this point.
We aren't quite there yet on the folding, unfortunately. Handling soft, unstructured fabrics is an incredibly complex physical robotics problem. But the washing machines themselves, like the new AI Wash Plus systems, now physically weigh the clothes you put in and use optical sensors to detect the specific soil and dirt levels to autonomously determine the exact amount of water, detergent, and cycle time needed.
So I don't have to just guess if permanent press is the right setting and hope for the best.
Exactly. You just throw the clothes in, and the agent inside the machine figures it out. It uses real-time sensor data to make the optimal decision.
That is actually incredibly helpful because I definitely ruin a lot of clothes by guessing the settings. But the energy management piece of the smart home seems like the most consequential shift for the actual macro infrastructure of the country.
It absolutely is. We are seeing the rise of grid interactive homes. Your house isn't just a dumb consumer of power anymore. It is actively negotiating with the public energy grid in real time. The house agent sells your excess solar power back to the grid automatically when neighborhood demand and prices are highest. And internally, it actively hunts down energy vampires.
Energy vampires. Okay, that sounds like a terrible teen drama on network television. Please tell me we aren't talking about actual vampires.
Fortunately, no. No garlic required. We are talking about that older video game console you haven't played in 3 months that is still secretly sucking 15 watts of standby power every hour, just waiting for a software update. Or the coffee maker with the glowing digital clock on it. The AI agent scans your home network, identifies these specific devices based on their unique power draw signatures, and physically cuts them off at the smart plug level to save you money.
I feel personally attacked. My house is absolutely full of energy vampires.
Most houses are, and the AI is the automated vampire slayer.
Now, we have to transition to talk about the invisible computer, because 2026 really seems to be the year where physical screens start to disappear, or rather they move directly onto our faces.
The smart glasses revolution. The industry is calling it the speckless revolution.
Speckless, what does that actually mean in practice?
It originally comes from an agile development method called speckless engineering, which was notably used by companies like Pytech. Instead of writing massive, exhaustive specification documents up front before building hardware, they just iterate rapidly with continuous clinical feedback. It is exactly how they have moved so incredibly fast in the medical wearable space. But for consumer smart glasses, the term has taken on a double meaning. It's about the physical hardware seemingly disappearing.
Right. The tech specs in the reports mention micro-LED waveguides and completely on-device AI brains. But walk me through the actual human experience. What does it physically feel like to wear these walking down the street?
Imagine walking down a busy street in a foreign city where you don't speak the language. You stop and look at a paper menu taped to a restaurant window. The English translation isn't on your phone screen in your hand. It is overlaid in real time directly onto the physical paper, perfectly matching the original font and color, directly through the lenses of your glasses. You look down at the sidewalk, and glowing pathfinding arrows are painted onto the concrete, guiding you to your hotel.
It's like having a video game heads-up display for real life.
Exactly. And for professional work, imagine you sit down in a crowded coffee shop, you put these glasses on, and suddenly you have 3 massive glowing virtual monitors floating in the air in front of you. You don't need to carry a heavy laptop anymore. It is the invisible computer. You are seamlessly manipulating digital objects in physical space.
But, and there is always a massive but, with this stuff, the privacy implications of a wearable device that literally sees everything you see constantly are massive.
It is what researchers call the privacy paradox. We all want the incredible convenience of an AI agent that remembers the name of the person we just bumped into at a conference, quietly whispering their name and company into our ear, or an agent that constantly monitors our skin for early signs of melanoma. But that level of proactive convenience strictly requires a high-definition camera and a microphone that are always on, always processing.
And unlike a smartphone that you can just put away in your pocket, these things are mounted right on your face. They're constantly pointing at everyone else around you.
Right. And society is still really struggling to figure out the etiquette and the laws around this. We are seeing a huge push right now for physical privacy shutters on the cameras, little mechanical slides you can close, and very bright, unhackable recording indicator lights. But the core risk of a device that records your entire life is massive. If your glasses get hacked by a bad actor, the hacker doesn't just get your PDF files, they literally get your eyes and your ears.
Which transitions us perfectly, if uncomfortably, to the heavy stuff. We need to talk about safety. The International AI Safety Report 2026 just dropped. This is a very big deal, right?
It is a huge deal. It is a massive, unprecedented collaboration led by Yoshua Bengio, synthesizing the absolute cutting-edge science on general-purpose AI, or GPAI. And the findings across the board are very sobering.
The comprehensive report breaks the specific risks down into three major categories: malicious use, malfunctions, and systemic risks. Let's start with malicious use. This is basically what happens when the bad guys get the tools.
Right. This is where bad actors leverage the exact same autonomous tools we just talked about. Cyber attacks are the big one here. The report explicitly finds that AI agents are dramatically scaling the preparation phase of complex cyber attacks.
What does that mean exactly? Scaling the preparation phase.
It means finding the hidden vulnerabilities. In the past, a skilled human hacker might spend weeks or months slowly probing a target company's firewall to find one tiny weakness. Now, they can just set an autonomous agent loose to continuously scan thousands of corporate systems simultaneously, analyze millions of lines of proprietary code, and report back the exact vulnerabilities to exploit in a matter of minutes. It completely lowers the technical barrier to entry for devastating cybercrime.
And deepfakes.
Deepfakes have become an absolute scourge. Non-consensual imagery, sophisticated financial fraud. The technical barrier to creating a perfectly convincing fake is now basically zero. You can clone a Fortune 500 CEO's exact voice from a podcast and have an AI agent call the finance department authorizing an emergency wire transfer, and it sounds absolutely perfect.
Then we have the second category, malfunctions. And there is a specific term in this section of the report that I absolutely love. Well, I hate the actual thing, but I love the word they coined for it. AI slop.
Oh, yes. AI slop. It is the perfect descriptive term.
Define slop for us officially.
Slop is that incredibly low-quality, generic, slightly hallucinated synthetic content that is currently flooding the entire internet and corporate communications channels. It is the marketing email that sounds exactly like a robot wrote it. It is the 5-page article that uses a ton of impressive-sounding words but actually says absolutely nothing of substance. It is the hyper-realistic generated image of a crowd where half the people have 6 fingers.
It is the digital equivalent of physical junk mail.
Yeah.
But it's being generated at an infinite zero-cost scale.
Exactly. And the macroeconomic cost of this slop is very real. If I can no longer trust that the urgent email from my actual bank is real, or if I literally cannot find accurate medical information on Google because it is buried under a mountain of cheaply generated AI articles, the entire digital ecosystem degrades. It fundamentally damages human credibility.
Then we finally have systemic risks. This is the stuff that slowly but surely changes the fabric of society. Let's talk about the labor market impact.
The safety report is actually quite nuanced here. It is not just the old cliche of the robots are going to take all our jobs tomorrow. It is more about a reduced demand for specific tasks like basic writing and translation. But more concerningly, it highlights a massive squeeze on junior-level roles across all industries. Think back to Devin, the AI coder. If Devin is doing all the work of a junior human coder, how do junior human coders ever get the necessary hands-on experience to eventually become senior human coders?
That is the broken ladder problem. You automate away the bottom rungs of the career ladder for efficiency, and suddenly nobody new can ever climb to the top.
Precisely. You hollow out the future workforce, and then there's a concept called automation bias. This one is genuinely scary, and I want to spend a moment on it.
This is the medical study mentioned in the report, right?
Yes. This was a fascinating study that looked at highly trained clinicians, professional doctors who are using advanced AI tools to help them detect tiny tumors in patient x-rays.
And common sense would dictate that human expertise plus AI precision equals a super doctor, right?
You would absolutely think so. But the data showed the exact opposite. They found that these expert clinicians actually detected 6% fewer tumors when they relied on the AI assistance over a long period of time compared to when they just worked alone or when they first started using the tool.
Wait, fewer? That makes no sense. I thought the whole point of the AI was to catch the tiny anomalies that tired human eyes miss.
It is supposed to. But psychologically, what happens is the human being slowly stops looking as hard. They begin to blindly trust the machine. If the AI agent flags a potential tumor, the doctor says, "Great, good catch." But if the AI agent doesn't flag anything on the scan, the human doctor subconsciously assumes the scan is perfectly clean. They completely outsource their vigilance to the software.
They effectively de-skill themselves. They lose that critical muscle memory of intense observation.
Exactly. That is automation bias in a nutshell. And it creates what Bengio's team calls the evidence dilemma. The deployment of the technology moves incredibly fast, but the rigorous scientific evidence of its harm, like that slow 6% drop in accuracy, moves incredibly slow. By the time we actually realize we have accidentally de-skilled an entire critical profession, it might be way too late to reverse the damage.
That is legitimately terrifying. It's exactly like using GPS on your phone.
Yeah.
I honestly don't know how to navigate my own city anymore because I just blindly follow the little blue line on the screen. But apply that exact same cognitive degradation to cancer diagnoses or building structural engineering.
Exactly. If the blue line on the map is suddenly wrong, do you still possess the cognitive ability to read the physical map and find your way home?
So we have all this incredibly powerful new hardware hitting the market and all these profound new systemic risks. But what practically happens to all the old stuff? The millions of laptops and servers we are actively replacing right now. MIT Sloan talks about something called the circular economy.
This is a really fascinating economic angle amidst all the tech talk. They coined a term for it, the circularity delta.
Circularity delta. It sounds like the title of a sci-fi spy thriller.
It does, but in economics, it refers to the massive financial gap between what large companies spend on buying new technology and what they actually recover when they dispose of it. Think about it. Global businesses retire millions and millions of perfectly functional laptops every single year just to upgrade. MIT Sloan rigorously estimates there is $3 to $4 billion in residual value just left on the table annually from retired corporate laptops alone.
3 to 4 billion. Do they just toss them in the dumpster? Or recycle them for basic scrap metal?
Often it's just sold for basic scrap weight, or worse, they literally just sit in a locked corporate warehouse gathering dust for 5 years because IT is afraid of data leaks. But in 2026, we are seeing specialized new software platforms emerge specifically to help huge companies securely wipe, resell, and recover the value of this hardware. It is finally closing the loop. It is not just about being environmentally green. It is about CFOs realizing they are throwing billions of dollars in the trash.
So the platform strategy, the Uber or Airbnb model, is extending deep into the physical corporate world. It is essentially a secure, high-volume marketplace for the corporate IT closet.
Exactly. It is turning physical corporate waste into a massive, measurable revenue stream.
All right, we have covered the high-level philosophy, the physical hardware, and the existential risks. Let's get really practical for a minute. For the listeners out there who want to get their hands dirty today, what are the absolute best of 2026 tools we are seeing highlighted in these deep dive sources? If I want to go build an autonomous agent tomorrow morning, where do I actually go?
If we look at general productivity and workflow orchestration, Zapier is still the undisputed king, but the platform has evolved significantly from what it was.
It is not just the basic if this, then that trigger system anymore.
No, not at all. Zapier now includes an integrated copilot that lets you build complex agents using plain natural language. You just type out what you want the overarching workflow to be, and the AI physically builds the integration paths. And they introduced a feature called Canvas to visually map out these insane multi-step agent workflows. It has basically become an entire enterprise orchestration layer designed for the non-technical user.
And what about for the actual developers, the people who want to look under the hood and write the code?
For them, the heavy hitters are LangChain and Prefect. These are the foundational tools for building and managing highly complex custom agent workflows. Prefect, specifically, is critical because it helps solve the observability problem.
Observability. That ties directly back to the shadow AI problem we talked about earlier, right?
Exactly. When you have dozens of agents running around doing things, you desperately need to clearly see what they are doing in real time. Are they failing constantly? Are they stuck in a loop spending thousands of dollars in token consumption? Prefect gives you that central command dashboard to monitor the bots.
And what about Amazon Bedrock? That was heavily featured in the Forrester report.
Bedrock is incredible. It gives developers instant API access to 83 different foundational LLMs. It is the ultimate buffet of AI. If you want to build a highly specialized agent, you go to Bedrock to pick the exact brain you want to use. You can swap out an Anthropic Claude model for a Meta Llama model or an Amazon Titan model seamlessly depending on what specific task the agent is doing.
And finally, let's talk about research. We briefly mentioned a tool called Deep Research earlier. This is rolling out from both ChatGPT and Google Gemini.
This specific tool is the thing that completely replaces the traditional Googling phase of modern knowledge work, and this represents a massive fundamental shift in human workflow.
How so? Walk me through the difference.
In the past, if your boss asked you to research the long-term impact of climate change on Florida commercial real estate, you would do a search, open 10 different browser tabs, read through them manually, take notes in a separate doc, and try to synthesize an opinion.
The endless tab shuffle. I know it entirely too well.
We all do. But with deep research, you simply tell the agent, find me absolutely everything published on the impact of climate change on commercial real estate in Florida, but specifically focus on rising insurance premiums and new flood zone maps. And the agent goes off completely autonomously. It takes maybe 10 minutes. It actively reads hundreds of sites. It cross-references the data. It actively ignores the low-quality AI slop we talked about. And it writes a fully formatted graduate-level research report complete with inline citations.
It does the actual intellectual synthesis. It doesn't just give you links. It gives you the final answer. It saves hours of mindless tab switching.
It absolutely does. It moves the human worker entirely from the tedious phase of searching to the higher level phase of reviewing.
Okay, we have covered a massive amount of ground today. If I had to synthesize everything from these reports, I'd say we have truly moved from a world of asking computers questions to a world of delegating tasks to them.
That is the perfect summary. We are no longer operators, we are delegators.
The core technology is undeniably incredible. We have invisible computers on our faces, intelligently predictive homes, and autonomous digital coworkers. But that trust gap is the giant elephant in the room. We are hastily building a massive digital assembly line, but if we aren't extremely careful with our governance, we're just creating an insurmountable mountain of turbocharged technical debt.
And crucially, we are actively risking our own fundamental human capabilities in the process.
Which brings me perfectly to the provocative thought I want to end on today. We talked earlier about those expert doctors missing the tumors because of automation bias.
Yes, that terrifying 6% drop in detection accuracy.
So here's the question for you, the listener, to chew on this week. As these AI agents get infinitely better at handling the daily drudgery of life, the email scheduling, the grocery shopping, the basic coding, the preliminary diagnosing, are we effectively de-skilling ourselves as a species? In 2026, we are undeniably gaining unprecedented efficiency. But are we quietly losing the vital muscle memory of critical thinking, deep observation, and struggle?
It is a profoundly important question. Because if you never have to navigate a city physically, you completely lose your internal sense of direction. If you never have to painstakingly draft a highly difficult, sensitive email to a client, do you eventually lose your human ability to communicate with real empathy and nuance? If you never have to hunt for a frustrating bug in a million lines of code, do you still truly understand how the underlying system works at all?
Exactly. If the digital agent does all the hard thinking for us, do we eventually forget how to think for ourselves?
That is the ultimate systemic danger. We absolutely need to make sure we are purposefully keeping humans in the loop, not just for operational safety and preventing AI slop, but simply to keep our own minds sharp.
So, as you go through your week, take a hard look at your own daily workflows. Where can an AI agent genuinely help you save time? But more importantly, where must you stubbornly stay in the loop to protect your own skills?
Don't accidentally delegate your own humanity for the sake of efficiency.
That is a perfect place to leave it. That is it for this deep dive into the agentic era. We will see you next time.